All right. Now that we have basic understanding of how Pipecat works architecturally, just to recap, it's a pipeline with couple of frame processors, and then you have frames flowing from top to down, right? And it all runs in a task. We will create our first simple Hello World agent, which will have nothing configured. It will just be a gateway between OpenAI and us, where our voice will go through the pipeline and then responses will come back, right? So let me just start by creating a virtual environment. Okay. So once we create a virtual environment, we will need to install a couple of packages. So those are Pipecat AI. Then we also need to install uh, web sockets for socket connection. We would need to install fast API for a API server. We would need to install .env to load configuration variables and UVCon server. Yeah. Right. So now that we have our workspace set up, we will start by creating an agent folder. Okay. This agent folder will hold the logic for running our agent. So first of all, we will be adding all these frames to our pipeline, right? So these two frames would be responsible for delegating input and output to the respective transports. We will come to this context aggregator later, and then we'll STT, LLM, and TTS, right? So first of all, we need to take in the base transport. So we will be using abstract transport, which means that anybody who use the agent takes the responsibility of providing transports. The reason being that we want to keep our agent composable, they should be able to run on any transport. In a real environment, you would be running different transport in dev mode. You might be running different transport while testing, and then you would might be running a different transport in production, right? So we want the agent code to stay the same. Then we will expose a method called runbot, which is where we take in the transport. Then first of all, we will read the environment variable and then we'll get our API key, right? I will be using OpenAI for this project, but you are free to use any other services provided by Pipecat, integrated with Pipecat, or you can create your own transports as well or own services as well, right? So first things first, we will need the STD service, right? So let's configure our STD service first. So STD service first takes in the API key and then we also need to pass in the settings, right? So for settings, we just have a model. So model we are using is GPT-4o transcribe. You can find better models if you wish. Then we will configure the LLM, which is the thinking part, right? So this is where a thinking part will go. Again, this takes the same parameters. It needs a model to think, and then it needs API key to authenticate with OpenAPI. And then we have TTS, which is the last part. So this is where we configure the text to speech part, and then we use the TTS part. This is where this is has a lot more instructions to it. First is the voice. You can refer to OpenAI documentation to see what different voices are available, and then you provide some instructions to it. Now remember that these instructions are not for the agent. These instructions are for the voice model to generate voice, right? So, for example, this is essentially setting a tonality. Okay. Then now comes the important part, right? You see that we have aggregators, and I've talked about this in previous video as well. So what's really happening is that you are receiving a lot of frames. Now you need a place where you aggregate those frames to create one big chunk, right? Because you won't be sending, for example, 1 second audio might contain thousands of chunks. So you won't be sending each chunk to STT separately. You would be waiting for first to complete all the chunks. Then you would be using some voice activity detection model, which will help you detect when user has stopped speaking, and then you send those audio packets forward, right? So coming back, so we will first need an object to hold the context, right? Which is our LLM context. And then we need a voice activity detection analyzer to detect what voice activities are there, and then intelligently pause whenever needed and then send those frames down. Then we would need these aggregators. So LiveKit provides this aggregator pair, which takes in both assistant aggregator and the user aggregator, and then it's our duty to plug them in the right place, right? So there is actually a mistake. So this should be like this, because we first need to take in the speech and then we would need to aggregate it, right? So we configure our aggregator where we have user params and then we have assistant parameters, right? And then we will create our pipeline. So we first import the pipeline and then we create a pipeline, right? So here, as you see, it first takes in the input, which we have provided by transport. Then we have STT, and then we have context aggregator user, then LLM TTS output, and then we have assistant. So the right order would be something like this. Now the job of assistant is very simple. Assistant aggregator is very simple. It just collects all the transcripts and creates messages out of it, right? Because while you are storing messages, you won't be storing messages in chunks. You want those messages aggregated in a single sentence or maybe in a uh, single string, right? So this is where pipeline comes, right? Now that we have pipeline baked in, we also need to create a task for it, right? So let's go ahead and we need a pipeline task and pipeline parameters for this. We create task, we enable a few things, then we create a runner out of it, and then we run the task. So this does the job of running an agent, uh, and this takes in an arbitrary transport and then it runs it. So now think from a perspective where you are calling this function, you need to provide a transport, and then that pipeline would run on that transport. Right. So now we will move ahead with creating the fast API server for it. With building the fast API server. So I just went ahead and pasted the boilerplate code for fast API server. This is available on the Pipecat examples repository, where it just creates a simple fast API server, then it loads it, allows cores on it, and then it loads it into a UVCon server to be served in production, right? This in itself is a very is a bit complicated code, but it is out of the scope for this video. So maybe you can use AI tools to get more information about it, right? But for this video, we will be completing this method where we are actually accepting the WebSocket endpoint, right? So here we will go ahead and actually create a WebSocket transport, which is fast API WebSocket transport, and then we will run our pipeline on it, right? So let's see this in action. So first of all, we accept the connection and then we enter the try catch block, and this is where we will be creating our pipeline and transformation, right? Transform. So first thing is we need to have this fast API WebSocket transport, and in this we first instantiated the transport, right? Then we configure this. So we configure the right audio headers. We allow audio. We are not allowing video because our application doesn't need any video, right? But it can handle video as well. One thing is that we would also need to serialize the audio files, right? So to serialize, we would be using protobuf frame serializer, which again comes packed in with a Pipecat, right? Once you have all this, the next step is to import the actual runbot function which we created from agent, and then you need to plug it inside a WebSocket transport, right? Yeah. So now that our server is configured, we would also need a front end to connect with it. I will be just pasting the front end which is available in the examples repository as it is good enough for us. Okay, and then we will have a short walkthrough from it. Right. So this is the front end code. This is provided by the daily example repository, where it's just a front end which connects to a given WebSocket server. Right. Let me set this up. So we navigate into front end. We do a yarn install. We install all our dependencies. Once the dependencies are installed, the next task is to just start it up. Right. So we can do yarn dev, and this should start our front end. And then we also need to start our backend, right? So we will do uv run main.py. Before doing this, we will also need the environment variable, which is my OpenAI API key. I will just bring it in. Right, so we have our key present, and now we can start the server. Right, internet. So while this gets started, we can visit the front end where it has these two buttons, which is connect and disconnect, and it will locate our WebSocket server and connect to it. Right. Yeah, so our UVCon server is running on 7860, and now we can try connecting to it. So looks like the connection is set up. Uh, yeah, so it can. Yeah. So now AI can hear me, right? You can hear me, right? All right. So this is how AI is now talking to me, and this should be pretty much it for a Hello World project. And now we will, in future, we will dive deeper into various aspects. We will be providing more granular instructions. We would be implementing tool calls and everything else. So I think this should be it for now.